This is lesson 3.8, rates, ratios, and percents. When we finish, I want you to be able to apply your knowledge of rates, ratios, and percents to solve real problems. Now let's take a minute to look at some of the terminology and concepts we're going to be talking about. So if A and B are two quantities measured in different units, the rate of A per B can be written as A over B, A divided by B. It looks like a fraction now. Let's look at an example that's a little more concrete. So if it's $2 to buy 5 cans of soup, well, if you want to know the price per can, you're going to put the price of the soup divided by the number of cans. So then you get 2 divided by 5, and then you're going to get the unit price. So each individual can of soup cost 40 cents, or 40 cents per can. Now when we talk about unit rates, it's really important to know that rates are often expressed as unit rates. And a unit rate is a rate per one given unit. One that we talk about a lot in our daily lives would be miles per gallon. So look, my car on the highway gets approximately 26 miles per 1 gallon of gas, but we usually don't say that one, we always just say per gallon. Okay, now let's take a moment and let's look at this problem. Okay, when I look at this problem, they want to know how I can relate this information to individual spending. This was in 1996, very important information. The estimated spending in 1996 for clothing and shoes was $183 billion. For restaurants, it was $190 billion. And for food at home, it was $300 billion. So they want me to relate this information to individual spending. Do I have what I need to do that? Do you know what else I need to know? Well, they want me to relate this to the individual spending in 1996. Well, how many people were in the United States in 1996? So I need the population. Now the population in 1996 was about 266 million. So what is it that I'm wanting to know? I need to use a unit rate, I think. I want the money spent on clothing per individual, so per person. So sometimes when you have trouble figuring out where your numbers need to go, think about your unit rate, what it is you're wanting to figure out. I want to know the amount of money spent on clothing per person. So I'm going to get my calculator out and I'm going to say $183 billion divided by the population, which is 266 million. When I plug that into my calculator, I'm going to get approximately $688 per person. Okay, now I want you to hit pause and I want you to do the restaurants. And when we look at the restaurants, it's 190 billion per 266 million people. When I plug that into my calculator, I get approximately $714 per person. Let's do the home, or food at home, I should say. $300 billion per 266 million people. Let's pull up our calculator so we can see what it looks like when we plug this in. So 300 billion. Okay, So 300 billion divided by 266 million gives me approximately 1,100, going to round up, $28 per person. Okay, let's take a look at the next problem. This time we've got collected data. You've recorded your car mileage and gasoline use for 2 months. I want you to estimate the number of miles you can drive on a full 18-gallon tank of gas. Well, before I can estimate the number of miles I can drive on an 18-gallon tank of gasoline, I've got to figure out how many miles I can go on one. So the first thing I'm going to do is I'm going to add up my total number of miles. When I add that up, I see that over this 2-month period, I've driven 1,149 total miles. Now, how many gallons of gas did I use? I'm going to add this up. And when I add that up, I see that I have used 47.4 gallons. Well, I want to know how many miles I can go per gallon. Look, it's already set up in a fraction for me. So I'm going to get my calculator out. I'm going to divide that. And I'm going to see that I can go approximately 24.2 miles per gallon. Now, once I know how many miles I can go on 1 gallon, I'm almost ready to answer their question. Estimate the number of miles I can drive on an 18-gallon tank of gasoline. Well, some of you are going to look at this and you're going to say, well, if I can go 24.2 miles on 1 gallon, I'm just going to multiply this by 18. So you're going to say 18 times 24.2. And you are going to come up with approximately, when you multiply this, 435.6. miles. Now don't worry if you didn't see it like that. There are other ways to get there. Remember, one of the things I love about algebra, there's so many different ways to get the same answer. One of the things I don't like about algebra, there's so many different ways to get the right answer. So let's take a look at one of those other ways. We're still looking, oh, what did we use up here? Miles per gallon. So when we looked over here, I know that my average is 24.2 miles per gallon, right? Do I know how many miles? I want to estimate the number of miles, so I'm going to use the variable m so it'll make sense to me. Miles per, well, how many gallons of gasoline do I have? Oh, I've got 18. And I know that after I finish dividing that, what's my average? I'm going to be close to 24.2. Now I can solve the equation. I've got m divided by 18. I'm going to use my inverse operations. Multiply both sides by 18. Oh my gosh, that's the same thing we did right there. So now I see that my miles, once again, 435.6 miles. Okay, now we're going to take a moment. We're going to use a little bit of unit analysis. This is something that would be very handy if you were traveling to another country and you needed to exchange money. That exchange rate changes daily. So let's say you're visiting Mexico and you want to exchange $180 for pesos. The rate of currency exchange on that date is 9.990 pesos per US dollar. You want to find out how many pesos you're going to receive. Now, I know we've been talking about unit analysis in class, but sometimes this will help you make things a little easier when you're not quite sure what's going on. What do I start out with? What type of money? I'm starting out with dollars. What do I want to end up with? I want to end up with pesos. So I have to figure out what's going to go on right here. What am I going to be multiplying by? What do I want to cancel out? Dollars. And I want to end up with pesos in the end. So if I do it this way, see how the dollars are going to cancel out from the numerator and the denominator. I've got the basic setup for my equation. Okay, now let's go ahead and let's start plugging in with what we've got. How many dollars do I have? I have $180. Now pesos per dollar. Okay, I get 990 pesos per US dollar. Remember, it's really per 1 US dollar. So pesos over dollars, so I'm going to multiply by 9.990. And when I finish, I'm going to get my pesos. So when I multiply this out, I'm going to get 1,798.2 pesos. Now let's take a look when you're ready to leave. When you leave Mexico, you find that you have 180 pesos left. You want to find out how many US dollars you will receive. The rate of currency has now, the currency exchange has now changed. It's now 9.987 pesos per dollar. So I want you to hit pause and I want you to create the unit analysis. Okay, let's see how you did with unit analysis. So you started with pesos. You wanted to end up with dollars. Who did you want to cancel out over here? The pesos. So you wanted to end up with dollars, so dollars was going to be in your numerator. Now let's plug in what we've got. I have 180 pesos. My exchange rate is now $1 for every 9.987 pesos. So numerator times numerator gives me 180. Denominator times denominator gives me 9.987. So when I divide, I have approximately $18 left. Okay, now we're going to take a moment to look at ratios. So we've got a group of tulips. We tested a sample of 50 tulip bulbs from a shipment of 4,500 for resistance to a type of mold. You found that 32 of the bulbs had a natural resistance and 18 did not. We're going to use these results to estimate the number of bulbs in the shipment that will have a natural resistance to mold. Now this is a great example of why ratios are so important. I cannot test all 4,500 bulbs. And one of the things that you're going to find is going to hold true is that the general ratio is going to be good to approximate values for larger sample sizes. Because if I test all 4,500 bulbs, I don't have any bulbs to sell anymore. My company's not going to make a profit. So the first thing you've got to do is you've got to see what you're asking. They're asking us to use the results to estimate the number of bulbs in the shipment that will have a natural resistance to mold. Okay, now let's look at my sample. How many bulbs were in my sample? I had 50 bulbs in my sample. Now I've got two numbers. I've got 32 and 18. You found that 32 of the bulbs had a natural resistance. 18 did not. I'm wanting to look at the natural resistance for the whole, so 32 is going to be the number that I need. So I'm going to be looking at the resistant bulbs in the sample. By the total bulbs in my sample. And because it's a ratio, I'm saying that this ratio is going to hold true. Even if I look at the entire sample, how many bulbs did I have altogether? I had 4,500. Okay, how many bulbs do I have that are resistant to mold? Well, I don't know. I've got to have a variable for that. I'm going to use R for my resistant bulbs. Now I'm going to plug in the information that I have. The resistant sample, I had 32. My total sample was 50. R is what I'm looking for. I want to know how many, on average, an estimate of the resistant bulbs I should have if this ratio holds true. How many total bulbs did I have? 4,500. Now some of you are instantly going to say cross multiply. And you're right, that's what you're going to do, but I want you to understand why that's what we do. Because when we solve over here, I'm trying to isolate R, right? Who's in the way of R being by itself? 4,500. It's divided, so I'm going to multiply, which is my inverse operation. What I do to one side, I must do to the other. So now I can simplify here. And when I multiply this, 32 divided by 50, I can get that number. Then multiply it by 4,500. So I get 2,880 is equal to R. So approximately 2,880 will be resistant. Now those of you who instantly wanted to cross multiply, this is what happened. You said 50R is equal to 32 times 4,500. Then you divide it by 50, which is the exact same thing that happened right here. But if you cross multiply without knowing the purpose or why it works, you're going to use it in a time that's not appropriate. Okay, finding percents. This question wants us to use the chart to determine what percent of 15 to 17-year-olds said that they are dating. And when we're finding percents, you do this every time you take a test and you look at your score out of the score possible. When you're finding the percent, you really have the part divided by the whole. So let's look at this for a moment. What percent of 15 to 17-year-olds said they are dating? 992 were surveyed. 482 of those said that they were dating. So the percent dating is 482 divided by 992. So when I divide this, I get approximately 0.4859, but that's a decimal. I'm going to multiply this by 100. So approximately 49% of 15 to 17-year-olds are dating. Okay, when we look at this problem, we're going to be using a graph. You're going to have to be really careful. The circle graph shows the percent of glass containers recycled in the United States in a recent year. About 3.2 million tons of glass containers were recycled. estimate the total weight of glass containers used that year. Okay, now they've told us that 3.2 million tons of glass were recycled. So that's this information right here. 3.2 million tons were recycled. The easiest way to solve this problem is going to be to set up a ratio. I want to estimate the total weight of glass containers used that year. So let's look at what I know. I know that 29% out of 100% was recycled. I also know that 3.2 million, that's the part out of the whole. So I also know that 3.2 million was recycled, but I don't know the total amount of glass. So from here, I can cross multiply if you're comfortable with what that means. Otherwise, just solve for your variable. And I get 29 times the total amount of glass is equal to 3.2 million times 100. Isolate G, which represents the total amount of glass used. So G, the total number of glass, is equal to 11,034,482 tons. But it wants us to estimate, so we're going to say it's about 11 million tons. And believe it or not, that's it.